Welcome again to another video. We're going to continue with radioactivity so that we can gain a further or a deeper understanding of radioactivity, the introductory video that we did earlier. Alright, so this question is a fresh sample of radon-222, which has a half-life of 3.8 days, was found to have a mass of 240 grams. Calculate the mass of radon-222 gas remaining after 15.2 days, giving your answer to two significant figures. So that's what we're going to be looking at today. But in order for us to first approach this question, let's just so the half-life is equal to 3.8 days. Okay? Now, so that's one thing we know. We know that the time is going to be equal to 15.2 days. So basically what we want to find out here is how many disintegrations took place within this time, right? So in order for us to find the number of disintegrations, we are going to divide the time by the half-life. So that's what we're going to do. So number of disintegrations okay? So it's the time divided by the half-life. So we know that we have 15.2 divided by 3.8, and when we calculate that, we're going to get 4. So what that means, there were 4 disintegrations during that time. And if you remember what we said about half-life is the time that a radioactive isotope took to decay to half its original value. That's what half-life is. So basically, where are we starting at? We are starting at what? 240 grams. So if you look, so this is our original, so we have 240 grams. So therefore, after the first half-life, it's going to decay to half its original value. Half of 240 grams is equal to 120 grams. So that's the first disintegration. Now, the second disintegration will now move from 220 grams to 60 grams. So that's the second disintegration. How many disintegrations are we working with? We are working with 4 disintegrations. So let's go again. So we have one more. So half of 60 becomes what? 30 grams. And that's the third disintegration. And then the fourth and last disintegration is going to be half of 30 grams give us 15 grams. So therefore, what this is saying is that after 15.2 days, we are going to have 15 grams left. This is basically what that is telling us. Now, this is the way this is just one method of doing it. What we're going to be doing after this, we're going to be looking at using the formula method in order to get the same answer that we have got here. Okay? So we recognize that the number of disintegrations was 4. So the number of disintegration was 4. Now, in the introductory video, we gave you a formula that says AO divided by AN is equal to 2 to the power n, where AO is equal to original activity, while AN is equal to activity after n half-life and n is equal to number of half so n is equal to the number of half-life. So let us just plug the values that we have got here into this equation, and then to see if we are going to get the same value as we did before. Now, so AO over AN is equal to 2 raised to the power n. So you can go back to that original video, that introductory video, and look at this formula again. But let's go. So we have 240 grams, because that's where we started, 240 grams, divided by AN is equal to 2. And we just worked out that the number of half-lives is 4. So therefore 4. Now, so we have 240 grams divided by AN is equal to 2 to the power of 4. Now, so therefore we have 240 grams over AN is equal to 16. Why 16? Because 2 to the power 4 is equal to 16. That is 2 times 2 times 2 times 2 times 2, and that will give us 16. So just transposing the formula for AN, then we have 240 is equal to 16 times AN. Again, AN is dividing over here, so when it goes across, it's going to go across as multiply. And here, in order to make AN the subject, we are going to divide both sides by 16. And dividing both sides by 16, AN is equal to 240 divided by 16 will give you 240 grams rather, divided by 16 will give you 15 grams. So basically, whether we use the formula or do the tedious method of working out, calculating the half-life after each integration, we would have got the same answer. So what this is simply saying, so we can always use the formula or the method that I showed you before in order to get the number of activities after a certain number of half-lives. So with this video, I hope that you will gain a better understanding of how to work out half-life calculation using the formula or deliberately working out the mass after each half-life. Thank you very much. Now, so again, thank you for watching. Thank you for watching this video. I hope that you will like and share it with your friends. Let them know that we are here helping you to prepare for your exams. So watch this video, share it with your friends, and do enjoy. And if you have not subscribed to the channel, please subscribe to the channel as we labor to help you to learn. So come learn with me as I help you and guide you.